Lesson 27, the binomial probability distribution. Example 12. According to Snapple, real fact number 52, 11% of people in the world are left-handed. In a classroom containing 32 students, find the probability that the number of left-handed students falls within 2 standard deviations of the mean. So here we're trying to find a probability. And since this follows a binomial random process, because a person is either classified as left-handed or not left-handed, 2 possible outcomes, we can use the binomial probability distribution to find this probability. In order to do that, we need to know the values of the 3 variables, the n, the p, and the x. Now, n represents the total number. So since we have a classroom containing 32 students, n would equal 32. And p would represent the probability that a student is left-handed. And since 11% of the people in the world are left-handed, p would equal 0.11. The value of the random variable x is based off of the probability question. Here we want to find the probability that the number of left-handed students falls within 2 standard deviations of the mean. So now we have to find what the range is that covers 2 standard deviations from the mean in order to determine what value of the random variable x will fit this probability problem. So to do this, we need to calculate the mean and the standard deviation first. Mu of x is the mean, sigma sub x standard deviation. And since we have a binomial probability, we could use the binomial formulas for the mean and standard deviation. Mu of x, the mean for a binomial, is found by taking n times p. And the standard deviation for a binomial is found by taking the square root of the quantity n times p times 1 minus p. Here, using the n equals 32 and the p equals 0.11, we find that the mean is equal to 32 times 0.11, and the standard deviation is the square root of the quantity 32 times 0.11 times 1 minus 0.11. Using the TI-84 calculator to help us with this, we can go 32 times 0.11, enter, to find the mean, which is 3.52. And for the standard deviation, we'd go second square root 32 times 0.11 times parenthesis 1 subtract 0.11, close parenthesis once, close parenthesis twice, press enter, and we find that the standard deviation rounds to about 1.77. Thus, we found that the mean, mu sub x, equals 3.52, and the standard deviation sigma sub x rounds to about 1.77. So now we can go 2 standard deviations from the mean by adding 2 standard deviations above the mean of 3.52 and then subtracting 2 standard deviations below the mean of 3.52. So here the mean is 3.52, and if we were to add 2 standard deviations, we'd add the 1.77 once, 1.77 twice. Subtracting, we'd subtract the 1.77 once, 1.77 twice to get the full range of 2 standard deviations. So here the mean was 3.52 plus 2 times the standard deviation of 1.77, enter, gives us the upper value of 7.06. The lower value is the mean, 3.52, minus 2 times the standard deviation of 1.77, enter, we get the lower range of negative 0.02. Thus, the number of left-handed students that falls within 2 standard deviations of the mean falls within a low of negative 0.02 up to a high of positive 7.06. Now, the random variable x, when it's binomial, is discrete, so we only get whole numbers only, because it's a yes or no. The student is either left-handed or they're not. There's no decimals in between. So the actual value of the random variable that falls within 2 standard deviations of the mean would be all the values from a low of 0 to a high of 7 and everything in between. Because 0 falls within the negative 0.02 on the low end, and 7 falls within the 7.06 on the high end. Thus, the number of left-handed students that falls within 2 standard deviations of the mean is the values 0, 1, 2, 3, 4, 5, 6, or 7. So now we can use the binomial probability distribution formula to calculate this result. Since the random variable x can be anywhere from 0, which is the absolute lowest x can be, up to 7, in this case, here we just need to find the probability that the random variable x is less than or equal to 7. And that is precisely what the binom CDF command on the TI-84 calculator calculates for us. So the probability that x is less than or equal to 7 is equal to the binom CDF using n equals 32, comma, the p is 0.11, comma, and an x of 7. The binom CDF command is found by going second, distr for probability distributions. We arrow down and put the cursor next to binom CDF and press enter to select. And then we enter in the 32, comma, the 0.11, comma, 7. Close parenthesis, enter, and we have our result. The probability rounds to about 0.980. Thus, in a classroom containing 32 students, the probability that the number of left-handed students falls within 2 standard deviations of the mean is 98.0%. So if someone was to go into a classroom containing 32 students and predict that the number of left-handed students would be anywhere from 0 to 7, that prediction would be correct 98% of the time.